Continue to prove that triangles are congruent. And so the two things that we've learned so far are side, angle, side, and side, side, side. Okay, so now we're learning angle, side, angle, and angle, angle, side. Okay, so it works out the same way that those other ones worked out. If you have, as you're going around, it's a little tricky when you're going around. So see how I have an angle with a side in between it and then another angle? That's angle, side, angle, okay? But if I go around the other way, so see how I had an angle, I didn't have a side, the next thing that I was going around was an angle, and then I had a side, that's angle, angle, side. Do you guys get how that works? Okay, so these are the two that are going to be, so if I have an angle, side, angle, and it matches up with the same markings, right? See how that one had 2 markings, this one had 1 marking, this one had 1 tick mark, right? They have the exact same markings, then we can say those two triangles are congruent. Same with angle, angle, side. So these are our new ones. Okay, we could try to draw things out on patty paper with string, whatever, and we would get that these are true. So number 1, so is it possible to prove that the triangles are congruent? So again, we mark in anything that we can. So if we know, oh, these share the same side, this MO, they're going to be congruent to each other, then now we have it set up so we can see it, it's angle, side, angle. Does this make sense? So this is going to be yes by angle, side, angle. And then write the congruence statement. So your congruence statement is going to be triangle MOP is congruent to triangle MON. Make sense? Do you like when it spells out words? Every geometry student's favorite thing when it spells out words. All right, so the next one. It looks like we could say VY is congruent to itself. Does it work? Can I use one of these things? I can say yes by what?
AAS.
Yeah, angle, angle, side, exactly. So if I want to say angle, angle, side, let's say I do Y, Z, V. So I sometimes look at my angles. I went from the blank one to the one with 1 marking to the 2 markings. So I'd say Y, W, Z. Does that make sense? Do you guys see it? Let me know if you're confused. A lot of people get confused on writing out the congruence statement. All right, so the next one we have parallel lines. So whenever you have parallel lines, you could use a little highlighter or something and you can extend those lines. So let's say this is our transversal. If I mark this angle right here, it's congruent to this other angle right here by what? What kind of angles are those? Yeah, corresponding angles. So then do we have something? Well, yeah, we had this marking, this 1 marking here and the 1 marking there. So we have yes by angle, side, angle. And so we can say triangle something is congruent to triangle something. So if I do EAB, I would say DBC there. Does that make sense? All right, and then how about this one? So I definitely have my parallel lines, and I have my transversal. So I could say like this angle right here is the same as this angle right here. Do the triangles have to be the same? Do I have any side markings? Could I get a side marking? Yeah, the shared one right there. Does that make sense? Reflexive property. So then I'm going to have, I covered up my letters now, I can't see what they are. So I'm going to have triangle FGJ is congruent to triangle HJG. Does that make sense? So this was yes by what? Angle, angle, side. Are you with me? Do you guys understand this? I know it's thrilling. The most exciting lesson you've ever learned right now. All right. So fill in the statements and reasons proof. Are you guys starting to feel more familiar, like more comfortable with proofs? Yeah, some of you guys are pros at proofs already. Some of you guys have been very, very good. All right, some of you are still working at it. It's okay. All right, so fill in the statements and reasons proof. So I have AB is parallel to DC, so I'm going to mark that in. Every single time you have parallel lines, I would look for alternate interior angles. That's probably our most common one that we use for these types of proofs. Okay, do we have any alternate interior angles? So if I extend this, and maybe this is my transversal, could I say this angle and this angle? Do you see the Z shape? Everybody sees the Z? Z shape. So it's inside of those two angles. those angles are going to be congruent. Okay? And I also know that AB matches up with CD. They're the same length. I just need one more thing, and I can do this multiple ways. So remember how your proof may not be like the person at next to you, their proof. Okay, yours could be totally different. So maybe you see this and you're like, oh, I instead wanted to use this transversal and these parallel lines, and I got these two angles are the same. That is totally fine. What other angles could I have used instead of those, though? I got a lot of lines on here. How about these two angles? Does that make sense? So your proof might be angle, angle, side, where maybe Max's proof is angle, side, angle, because he saw the other transversal. Does this make sense? So don't freak out if yours is different than someone around you. Okay, so let's go with it. So let's say that AB is parallel to DC, and then AB is congruent to CD. And our reason would be because that was given to us. And then once I drew in those parallel lines, remember the first thing I drew once I did parallel lines? Is I said, oh, let's extend it and cut it with a transversal to get these two angles. So I'm going to say angle B is congruent to angle D. And that was by alternate interior angles. And you could say postulate if you want to, or theorem. I think it's postulate, actually. Look. Or if you just write alternate interior angles, I won't cry. Okay. And then we say, oh, well, those angles in the middle, these angles right here are the same. So let's write it out with a few more letters. I can't just say angle E is equal to angle E. Do you guys agree? Different angles there. So I'm going to say angle BEA is congruent to angle DEC. And that was by vertical angles, right? So then our last step is, oh, ABE is congruent to CDE by angle, angle, side. I forgot my side right there. Maybe I should draw that in. I drew it in before, but forgot it the second time. Does that make sense? Okay. All right, so write a paragraph proof to show that TQS is congruent to RSQ. All right, so let's look at it. So sometimes it's hard when they're like overlapping. Students always hate the overlapping ones. So here's what I'm going to do. I'm going to draw this off to the side. And then I think you guys will really see it. So I'm going to do T had two markings, Q had one, and then S was all by itself. There were no markings on S. Do you see that? Okay, draw that off to the side. It will really help you. All right, and then we have a second triangle within that picture. So if you need to use a different color to see the second triangle, sometimes that helps. So here's our second triangle. I still have my Q and my S, and then I have an R up there. R had two markings, and S had one marking. Clearly not drawn to scale because these are supposed to be congruent, and my blue triangle looks much smaller than my red triangle. But you understand what I'm saying, right? You get it? Okay, we want to prove that these two triangles are the same. Okay, we have two angles that are marked. So what are our possibilities with two angles? We could do angle, side, angle, or we can do angle, angle, side. So if we can get that these were congruent, we could do angle, side, angle. Can I get TQ is the same as RS? I have nothing there to indicate that those are the same. Do you guys agree? So let's try the other one, angle, angle, side. So if I can do, going around, angle, angle, side, and angle, angle, side. So tell me why I can do that. Why is this the same as this? Yeah, what do you think, Rhett? Yeah, not same angle, same segment, right? They're exactly the same segment. Just one is QS, and the other one I'm going to read as SQ. Okay, but that's still the reflexive property. It's like angle 1 is congruent to angle 1. Side AB is congruent to AB. I don't have to call it AB and AB. I can call it AB and BA. They're the same thing, right? So we're going to say that. We're going to say that QS is congruent to SQ by the reflexive property. And then we already knew that angle T was congruent to angle R, and angle, so I don't want to say angle Q is congruent to angle S, I have to be careful. So I'm going to say angle TQS is congruent to angle RSQ we're given. Therefore, triangle TQS is congruent to triangle RSQ by angle, angle, side. Done. Make sense? Do you guys like paragraph proofs, or do you prefer the statements and reasons? Yeah. It's funny, like some people like the statements and reasons because they're like, I just want like these like little bullet points along the way. Like this is true, this is true, this is true, this is true. But then some people like the paragraph proof because they're like, well, sometimes I like to kind of ramble and kind of go around in circles and get there eventually. I don't have to do like step 1, step 2, step 3. I can just kind of put all my information in there somewhere. All right, so question. So I told you the one that spells out a bad word, ASS, or as math textbooks put it, SSA. So we don't write a bad word all over math textbooks. I told you that one doesn't work. And it's not just because it spells out a bad word. It legitimately does not work. Okay, very convenient for math teachers. All right, so here's why it doesn't work. So I don't know if you guys can see that little light lines drawn in on your paper. So let's say this was 20 degrees, and then this was 25, and this was 15 for my lengths. Oh wait, I don't want 15 there. I want 15 on my other one. And 15. Does that make sense? Okay. Imagine this segment that's marked with 15 is on a hinge. Do you guys know what a hinge is? Like a door hinge. So it's going to open and close. So I'm going to rotate this line right here. And I'm going to rotate it. Maybe I can rotate it on my little thing here. Let's try. If I could rotate this around and move it over here, I have another triangle that has those same measurements. I didn't change my angle here, I didn't change this length here, but now instead of having 15 going to the left, like downwards and to the left, it goes downwards to the right. Does that make sense? That's a second triangle with exactly the same measurements. So this 15 moved from here, and you could move it like on a hinge over. Does this make sense? Do you guys all see this? Okay. Those two triangles have exactly the same measurements. Their angles match up, their side matches up, and then the next side matches up. But those two triangles are not the same triangle. Do we all get that? Okay, that's why angle side doesn't work. Okay, because this shorter side could have been on the hinge and it could have pushed over here. Okay, so you have two triangles that have exactly the same. So number 4, so it says decide if the following triangles are congruent. If so, list the congruence postulate that was used. So what do we think on the first one? Are they congruent to each other? Yeah, by what? Yeah, SAS. This next one? 3 angles congruent? Angle, angle, angle. Can we say that?
No.
No. The most basic example of why angle, angle, angle doesn't work is if you think about even like an equilateral triangle and another equilateral triangle. Those all have 60 degrees, 60 degrees, 60 degrees, right? All the angles are the same, but those are totally different sizes. Okay, they could be different sizes, just a smidge bigger. I know those look the same, but maybe one length is 4.1 and one's 4.11 centimeters, right? They could be slightly different. So this is no. The next one? Why? Angle, angle, side? Ooh, I don't know. This is side, side, angle. So now Koki's bringing up a good point. This one actually will work for us. This is the only version of side, side, angle that works. Okay, so why with a right triangle might it work? So let's say I knew that this measurement was like 3 here and this was 5 here. Could I find the missing measurement? Yeah, and if this is 3 here and 5 here, wouldn't that have to be the same here and here?
Yes.
Yeah, they would have to. So this is going to be something that we will call hypotenuse leg. So yes, by HL. We're going to learn that later. So technically it does work. So I get a bonus one in there. All right, how about the next one? Does it work? Angle, angle, side? Yeah. The next one? Yeah. Side, side, side. And this last one? Yes. Side, angle, side. All right, question. What if I have that? Are they congruent? So Max is shaking his head. What did I do, Max, to make that tricky?
Well, they're not the same.
Yeah, they don't have the same markings, right? So if they don't have the same markings, they're not the same. Same as if I had done, like, maybe for these last sides I had done 1 and 2 like that, but then maybe my angle had 2 markings, right? Those aren't the same then. You have to have exactly the same markings. Make sense? All right. Is that the end of that section? Yeah. All right.